Behind all artificial intelligence systems today is computing power. More and more compute used to train the most successful AI systems. And this is a trend that has lasted not just for years, but for decades. Most of the advances in artificial intelligence have stemmed from using more data to train artificial intelligence systems, which in turn requires more computing power to use in the training of that data. This chart shows you the most advanced AI systems of their day over the last 70 years. And what you find is that there's been a consistent, extraordinarily rapid rate of increase in the amount of data used for training AI systems. The amount of data used for AI training doubles on a regular basis. And what's more, over the past 15 years, the rate of increase has only accelerated. This is what AI researchers, people at AI labs like OpenAI or Anthropic, refer to as the scaling laws. The intuition is that if you want a better AI system, you need a bigger AI system, a system trained on larger and larger quantities of data, which is why the AI systems that today undergird chatbots like ChatGPT are trained on almost all of the text that exists on the internet. And it turns out we're just getting started. We're finding more and more sources of data to use in training AI systems. And most of the optimism about improvements in AI over the coming decades stem from the belief that if we find yet more data and train yet bigger AI systems, we'll have better artificial intelligence as a result. And if you want bigger AI systems trained on more and more data, you need better semiconductors, because it's in vast data centers full of the most advanced servers with the most advanced chips inside of them that all AI systems are trained. This is why the world's biggest tech companies are more focused than ever before on getting access to the cutting-edge AI chips that are used in training these extraordinarily capable systems. And it isn't only tech companies that are focused on computing power as a core metric of success in the world of artificial intelligence. Governments are too. China, for example, has articulated a goal of increasing the computing power in China by 50% over the coming years. Countries from India to the United Kingdom have set out similar goals because they believe, just like all of the world's large tech companies believe, that better AI systems require more computing power, and therefore access to computing power, access to the cutting-edge chips that enable the training of big AI systems will be critical not just for technological advances, but for their economic and their political future. And if you look today at the distribution of computing power around the world, what you find is that there are two countries far ahead of the rest. Here's a chart put together by the Blair Institute of the server installation base by country, how many servers every country has installed. And what you find is that there are two leaders by far. First, the United States, far out in front of the pack. Second, China, clearly in second place, but also clearly ahead of the rest of the competitors. And it's no surprise, looking at charts like this, that there are also two countries that are setting the terms of the race to build AI systems. These are the countries that have access to the extraordinary volumes of computing power that are needed to train AI systems. And these are the countries that are competing right now to gain access to the cutting-edge chips that advanced AI training requires. And it's data centers like this that they're focused above all on building. Data centers, vast warehouses full of thousands and thousands of chips and servers into which data is surged as AI systems are trained. Data centers like this are rewriting the wiring of the global economy. They're reshaping investment in many different countries. They're attracting billions and billions of dollars from some of the world's largest investors who are betting that access to cutting-edge data centers will be economically critical in the future, because data centers like this are not only used for training AI systems, they're also used for deploying them. That's why AI data centers are being built not only in the United States and in China, but in many other regions of the world too. in Malaysia, the center of the data center boom in Southeast Asia, in the Middle East, where Saudi Arabia and the United Arab Emirates are trying to become AI hubs in the developing world. Many governments are focused on data centers like this as a tool of power in the modern world. And it's forcing changes in how big tech companies operate. Because if you want a cutting-edge data center like this, you need extraordinary volumes of energy to power it. More energy than data centers have ever consumed before. And this is why some of the world's biggest technology companies are now also becoming some of the world's biggest energy investors. Whether it's Microsoft or Meta, Alphabet or Amazon, they're spending billions, and in some cases tens of billions of dollars building and buying power directly. Because in certain regions, like in the United States, we're seeing the first increase in demand for electricity that we've seen in decades. And it's being driven above all by data centers. It's artificial intelligence that's demanding more power than ever before, which is forcing tech companies to look harder than they've had ever to look before to guarantee they can get access to the power that they need. That's why, for example, many of the leading AI entrepreneurs have themselves personally invested in projects to build fusion reactors. It's why Amazon recently announced it was buying a data center located right next to a nuclear power plant, giving you a sense of just how critical power supply is for these cutting-edge data centers. But of course, the biggest challenge in building an AI data center is not getting the land or constructing the building or even accessing the power, challenging though that can be. The biggest challenge is getting the chips that go inside. Because at the core of artificial intelligence systems are many different types of ultra-complex, cutting-edge semiconductors, which make it possible both to train and deploy the types of AI systems that are now being rolled out. And today it's hard to get access to all of the chips that you need. Not just hard for people like you or me, hard for people like Sam Altman, founder of OpenAI, who just a couple months ago was tweeting his apologies that he had to slow down access to certain ChatGPT services because even OpenAI couldn't get access to all of the advanced GPU chips that it needed. It's these chips, the GPU, graphics processor units, and the high bandwidth memory that they're coupled with, which are the currency of the AI era, the most important commodity, and also a commodity that until very recently has been in extraordinary shortage. And if you want to understand the economics of artificial intelligence or the geopolitics of AI, you've got to trace AI all the way back to the chips that AI systems are trained on. And you'll find, as I'll discuss in the remainder of my remarks, that the supply chain of companies that produces these critical chips is extraordinarily specific and concentrated, which creates great monopolies and extraordinary profits to the companies that play a role in producing the computing power that AI requires, but also creates extraordinary vulnerability, given that many of these critical chips are produced by a single company. Something that, in an era of intensified geopolitical competition, is, in a lot of ways, a very dangerous risk.